The eye of Hurricane Joaquin never got closer than about 350 miles to the east coast, but I can think of at least two reasons that the storm will not be forgotten anytime soon. Most obvious is the catastrophic flooding in South Carolina. Though this CNN headline was off base in saying that the hurricane was slamming the east coast, Joaquin did play an indirect role in the historic rainfall, which totaled more than 10 inches in about half the state, 20 inches in spots. A multi-day rainfall expected to occur once in 1,000 years, 2 to 3 inches per hour falling at times, 11 trillion gallons of rain total dumped on the Carolinas, enough to end the drought in California. Here's how it happened. A front had stalled offshore, the same one that brought more than an inch of rain here early last week. And behind that front, low-level cool air had taken over the Carolinas, while a non-tropical low, not so much at the surface but aloft, stalled over the south, circulating moist ocean air toward the front and overrunning that cool low-level air. That flow came off the warm Gulf Stream and nearby waters that were 2 to 4 degrees above average, adding instability. And though Joaquin was well offshore, its circulation took truly tropical air from the south and then redirected it toward the Carolinas, increasing the moisture pipeline. Now, to measure heavy rain potential, we sometimes compute what's called moisture transport. A good level at which to do this is 5,000 feet. We multiply wind speed by a measure of moisture called the mixing ratio, the number of grams of water vapor per kilogram of dry air. A typical value is about 10. A typical wind speed is about 20 miles per hour, so a typical moisture transport might be 200. And here's what it was Saturday night, and really for about 3 days, a bullseye in South Carolina of 600, the product of both excessive moisture and a persistent and speedy low-level jet right from the ocean. Joaquin also made news because of its forecast. The computer models really disagreed on its track, and the Hurricane Center was in a bind because of how it draws the so-called cone of uncertainty, which is actually based on average track errors over the last 5 years and not on how predictable a particular storm is. As an example, here's the forecast from last Wednesday, an ominous track down the middle of the cone aimed right at New Jersey. The whole cone essentially aimed at the East Coast. But now here's the forecast at that time from the European model and the American model, the GFS. They were so different, neither was actually in the cone, which essentially split the difference. In reality, the track down the middle wasn't likely at all, and the cone itself was not very useful. So basically, Joaquin exposed a shortcoming in the Hurricane Center's forecasting system, which is just not built for this situation. I suspect there will be plenty of discussion in the months ahead at the Hurricane Center about how to better incorporate uncertainty into their forecast products. Fred is back next with the extended forecast.